Hello students, we are back and we're going to continue talking about kinetic energy, the energy of motion. So remember, two main types of energy. We have potential energy, energy of storage, or energy waiting to happen. And then we have kinetic energy, the energy of motion. And we learned about some types of kinetic energy, such as electromagnetic energy, which is light energy. We learned about motion energy, which is the energy of motion, like a roller coaster, and that's the typical form of kinetic energy that we usually think about. But there's also a third type. We learned about three types of kinetic energy so far. We learned about electromagnetic energy, which is the light energy. We learned about heat, or thermal energy, which is really... So we learned about three types of kinetic energy so far. We learned about electromagnetic energy, which is light energy. We learned about thermal energy, which is the vibration of the atoms. And we learned about motion energy, which is really the most common form. The form that we usually think about, it's not the most common, but it's the form we usually think about when we talk about kinetic energy. So the kinetic energy, motion energy, like in a roller coaster movement. So the next type, the fourth type of kinetic energy is sound. Sound waves. Sound travels through waves. And sound needs particles in the air to travel through, or it needs to have a medium to travel through. So it is a type of mechanical wave. Remember, mechanical waves have to have a medium through which to travel. And sound waves is a type of mechanical wave. So when sound is made, it's really compression of particles in the air. Compression and then expansion. And then when they compress and expand, it sets kind of off like a chain reaction. So there's compression, expansion, until it gets to your ears. And then you process sound through your brain. You hear things. But it happens because there's compression and expansion of the atoms in the air. Sound travels in waves. And when an object moves fast, it compresses the air particles around it, or the atoms in the air around it. And when it does that, it compresses them, and then that compression leads to an expansion, which kind of causes like a chain reaction. So you have compression, expansion, until it gets to your ears, and then you process the sound in your brain. So that is what sound is. It's really the energy in the particles of the air. And so sound does not there's no sound in a vacuum. So in space, you can't hear. If you scream in space, nobody hears you. So if you're like, help, nobody hears you. So because there needs to be particles in the air. There needs to be a medium through which the sound travels, but it travels in waves, and it's a different type of wave than electromagnetic waves. So let's look at the types here. So pretend we have a slinky, and we're going to do a couple different types of waves. If you have a slinky at home, please do this. So the first one we're going to look at is a review of the electromagnetic waves. And we said that the electromagnetic waves are a form of transverse wave. Let's say we're holding on to ends of the slinky, and we move one end up and down. So the wave is going up and down. The wave is going that way. But the direction the wave travels is going this way. So it's moving through the slinky. So is perpendicular to the direction of the wave. So that is a transverse wave. This is how electromagnetic waves travel. So light waves travel this way. Sound waves waves travel differently. They travel in waves called longitudinal waves. So if you take your slinky and you just push one end real fast, it creates the wave. And in this wave, the direction the wave's going and the wave itself is going the same way. There's energy in the air particles. There's a compression and expansion of these air particles. And they have energy in them. And the direction of the wave is the same as the height of the wave. So the wave is going this way. When you push it, like you take the slinky, you push that way. I'm pushing this way, and the wave, the direction of the wave is going the same way. Okay, so they're both going the same direction. That's longitudinal. However, I take the slinky and I'm going up and down. That is transverse, because I'm going up and down, but the wave is actually traveling this direction. So they're perpendicular. The fifth type of kinetic energy is electrical energy. So electrical energy is energy produced from the flowing of electrons. And the flow of electrons is really electricity. Magnetism is included in electric energy. So electricity is really the flow of electrons. And remember, electrons are spinning around the nucleus of the atom. Remember, those are the parts, the subatomic particles that are spinning around the nucleus. And in metals, remember metals, metalheads, they lose their electrons easily. They can give up their outer electrons. So remember, they become oxidized. Remember, lose electrons, oxidized. So metals lose electrons. And that way they're good conductors of electricity because they lose the electrons. And when the electrons are lost, they can travel through the path of a circuit in electricity. So if we take a battery, for instance, let's say batteries have two ends, a positive end and negative end. There is chemical energy in the battery, stored energy in the battery. And when a battery is put into a closed circuit, when it is connected to electric wires made of metal, it provides a highway for the electrons to travel. So batteries that are not in a circuit are just stored energy. But to convert that stored energy to the form of electrical energy, which is a form of kinetic energy, we put the battery into a circuit. So when you put the batteries in your remote control, the batteries in a drone, you're putting the batteries in there, you're closing the circuit. It's an open circuit. When you put the batteries in, you close it. So when you close it, the electrons flow out. And this is the same that happens when you click the lights on, the light switch. So the light switch closes the circuit. So the electrons travel. And they go through the pathway, and along this path, you could have lights, so light something up, provide the energy to get a toy to move, whatever it's programmed to do, but it's going to cause these electrons to flow through a pathway called the circuit. So this is electricity. And this is kinetic energy because this is kinetic energy because it's energy of motion. The electrons are moving. So when electrons are moving, it's called electricity. And they can move through a circuit. So a circuit is like the pathway upon which the electrons will travel. So those are really the 5 main types of kinetic energy. So now we know about the types of energy. We have potential energy, we have kinetic energy, and then we have different types of potential energy and kinetic energy. So energy really is just energy's ability to do work. And there are many forms of energy, but energy is not created or destroyed. It is just simply transformed from one form to another. Stated in the first law of thermodynamics, or the law of conservation of energy. So energy is awesome.